So good afternoon. Now, welcome back. I think it has been quite some break since you started doing the exams. I think we have not met for some time. I would like us to go through a recap of what you have covered so far. Today, in the first place, I would like us to discuss about file organization. We, however, have so far covered lesson 1 up to 5. In lesson 1, we had an introduction to computers, and here we just basically had a definition of terms: computer, its roles, the history of computers, the characteristics of computers, the types of computers. I think at your own free time you can go back and revisit that and get to see what is there, and it is important for your own revision. In lesson 2, we discuss about computer components and their functions. This is where we actually did mention about the input function, the processing function, the output function, and the storage function, and of course discuss a little bit to do with the components that do that. And we also mentioned about the CPU and the registers it has, the buses. We mentioned about the displays, that is the screen, and the technologies they use. That's where we have, I think, a discussion between LCDs and CRTs, a comparison, flat screens, and so on. We also mentioned a little bit to do with storage and related technologies. We talked of optical, we talked of optical technology, storage technology like is used in CDs and DVDs. We also talked about magnetic storage technology like is used in tapes and hard disks. That kind of a thing. You can check again in lesson 2 and see what more is there. In lesson 3, we started memory hierarchy, and this is where we said that the computer storage can historically, we all want an unlimited storage for any computer, and so that it can store as much as we want. And number 2, we want it to be fast. We want our computers to be fast. If you have a laptop or a desktop that is slow, you get annoyed even when you're working with it. You want it to load as fast as possible. You want when you save your work to be saved immediately. You want when you want to open a movie and watch, you want it to be fast. We want a fast computer. Part of that speed is controlled by how fast the processor is able to access the memory. So you want a memory as fast as the processor, or almost working at the same speed as the central processing unit. But this would be too expensive. It would make our gadgets too expensive. We look at what our interests are. Our interests are having big storage. That means capacity, huge capacity for storage. We're also interested in having high speed. And then we ask ourselves one question: are there compromises we can make because it is not possible for us to have both? And the answer is found in the hierarchy, the memory hierarchy, in the sense that high speed memory, which is expensive, is provided in low capacity so that we reduce on the expense and still be able to enable the processor to work at high speeds with what it operates on currently. So we provide the registers in the CPU, we provide the cache memory, we provide the we provide the we provide the main memory, and we also provide the auxiliary storage, the hard disk and the auxiliary storage, the tapes and whatever else, DVDs. And the lower you go in that hierarchy, the higher the capacity and the slower the speed, because we are storing things for future reference. But the closer you move to the processor, the higher the speed, the higher the cost, the lower the capacity. And that is designed to enable us have an efficient and effective memory organization. That was it, and if you want to know more, you can check what it is in lesson 3. In lesson 4, we discussed about the processor architecture, and here is where we talked about the reduced instruction set computer and the complex instruction set computer. These are the two main architectures. Of great interest here was also the fetch execute cycle, where we discussed about the instruction fetch cycle, the decoding of the instruction, the fetching of the data in case that instruction requires data, the execution of that instruction, and the storage of results. And those we discovered are the steps in the execution of any instruction. But we also discovered along the way sometimes you can have an interrupt. Therefore, we have interrupt handlers. I mean, you can read further for yourself to remind yourself. In lesson 5, we had memory organization. Now, memory hierarchy, memory organization. In memory organization, we revisited a little bit to do with memory hierarchy, but then we went into the components of this memory. We discussed about the CPU registers. We mentioned the cache memory, the main memory, the the auxiliary storage, including the magnetic and optical storage. And we discovered the CPU operates at almost a speed as high as that of the the registers work at a speed as high as that of the CPU. Then we have the cache memory operates in nanoseconds. The main memory operates in microseconds, and the the hard disk, so to say, operates in milliseconds. Optical storage, of course, operates lower at a lower speed than that. So in other words, as you move from the CPU towards the auxiliary storage, the speed lowers. So we discussed about the RAM. Remember, if you remember, we mentioned in the memory organization, we mentioned about the dynamic RAM, the synchronous RAM, the synchronous dynamic RAM, that is synchronous DRAM, and the RAM bus DRAM. We ought to know about this, and of course the differences amongst them. We also talked about the access methods, sequential, direct, and you can read further about the sequential methods used for accessing content that is in either the hard disk or auxiliary storage or the main memory. What kind of access method is used? We mentioned about the hit rate and the miss penalty with respect to cache. Okay, those files which are referenced quite often are held within the cache, the cache memory, which is between the random access memory and the CPU. So when the CPU wants to check for a file before it accesses the main memory, it has to check whether it is there in the cache. If it's not there in the cache, then we say there is a cache miss, or there is a miss, and then if and that miss results to the time spent going to look for it in the main memory or in the hard disk in order to load it in the main memory. That time is what we call the miss penalty. But sometimes we hit. In other words, the CPU will find that the file is in the cache. Then we say that's a hit. Then we talk of the hit rate and the miss penalty. You can remind yourself more about that as you read the memory organization. And then we talked about the virtual memory. Remember the virtual memory aspect? Sometimes you want to load a file into the main memory, but the main memory is limited in capacity. Remember, it is already holding the operating system. Now you have added the files you want to run. At some point you find that you can exhaust it so easily. So what happens is, the main memory is organized into sections called pages, so that you load, not the main memory, but the files which you are loading into the main memory are organized into pages, so that you load those pages that you want to use at that time, and the others are held back in the hard disk and only called when needed. If there is not enough space, you will keep on swapping. You remove some pages, you take them back. The operating system removes the pages from the main memory, takes them back to the virtual memory within the. Of course, the virtual memory is established within the hard disk, and then you pick those that are needed now and you load them in the space available. That way, the virtual memory becomes like a virtual extension. Indeed, it is a virtual extension to the main memory. And I think that is where we were. So you can revisit the main memory and learn more about the virtual or the paging concept. It's a very important concept actually in memory organization. So having said that, I would like us now to shift into file organization, which is lesson 6. And I intend to cover these lessons. At the end of this lesson, I'm going to give you Cat 2. So you can check on the online platform. I think I'll be the online platform. Probably I shouldn't log in right now but this is it. You already had done a quiz. Don't know whether there are 2 quizzes. The last, if I go to lesson 5, it was quiz 1. So you're going to do a quiz 2, and then probably you're going to have a Cat 2, so that everybody has a taste of the quiz. Having said that, then I would like us to continue with file organization. We will visit the issue of quiz and Cat later. Well, we have seen the organization of the memory. We have seen the organization of the the computer architecture, processor architecture. Now I'd like us to focus on how are files organized. In the first place, what is a file? So let us acquaint ourselves with terms which are used with file organization, and then we look at the content of file, the depth. We deep dive into file organization. A file is a named collection of stored data that has some size, date of creation, order, attributes, organizational method, that is data storing and access, and is of some type. So if, for instance, we go to what we have in this folder, there is a way in which we can probably display content in this folder, so that you can see those properties you're talking about. Can you see some of those properties here? The date it was modified, the type, the size. These are some of them. We are quoting them here now. A file is a named collection of stored data that has some size, date of creation, other attributes, organization method, and so on. And of course, it's of some type. Like here we have PDF files. If you right click on any of them and check the properties, you see what you're talking about. Type of file, location, where it's located, size on disk, when it was created, when it was modified, when it was accessed. Yeah, these are the things you're talking about. Even there are security features and so on and so forth. But the general are the ones which have been mentioned here. This is what you're talking about when you're talking about you're defining a file. It consists of a number of records which are made up of related fields. Each consists of characters which are in turn made of bits. The purpose of a computer file is to hold some data that is required to provide some information during processing. Some files are processed at regular intervals to provide information, that e.g. payroll files. Others will hold data that is required at regular intervals, e.g. the file containing prices of items. Others will hold data that is, required after long times. A file can be viewed in two common ways: either as a logical file, that's schema, or as a physical file. I've just shown you an example of a physical file. The logical file, in this view, which is based on what data items its records contain and what processing operation may be performed upon the file. And this is always the view of the user. Reference is made to a logical record or an entity and the data item or the attributes of the entity. Entities or objects are things, things we want to hold data about are the ones we call entities. So we have a record about an entity. That is what we call the attributes. The collection of attributes makes a single entity can have a record which is a series of those attributes regarding that item. And when you have several of these records, then you have a file. Of course, the individual properties of the entity are the ones we are referring to as attributes. And for instance, we have like invoice, you have name, address, customer, order. You know that thing from database. From your study of databases, then you might be having an idea. A logical record is created for each entity occurrence, and the logical record contains one data item for each occurrence of the entity's attribute. E.g., customer's name would be the data item, and there would be one only in the logical record, whereas the attributed quantity would have as many as there are entries on the invoice. Now the physical file, this view is in terms of how the data is stored in the storage device, such as the magnetic disk, or how the processing operations are made possible. And we really work from this view as users. Now let's look at fixed length and variable length records. Now that we know about the files, I don't know about the records, I don't know about the entities. Fixed length records, every record in a file will be of the same. In fixed length record, the file will have the same fixed number of fields and characters, and will never vary in size. In variable size, then this means that not all records in the file are of the same size. This could be caused by two reasons. Some records could have more fields than others. That's possible. Or the fields themselves could vary in size. Fixed length record make it easy for the programmers because dealing with a known quantity of characters at a time. On the other hand, they result to less efficient utilization of storage. A variable length record means difficulties for programmer but better utilization of the storage space. We have certain file characteristics which you can look at. Every file must have the following characteristics. It should have an identifier, that's the name that the file can be addressed by. Its size, every file must have some size. This is known by the number of bytes it occupies. Date of creation, modification, this reflects its age. Author or user, this is the person who created or whom it was created for. Organization, this is the mode in which the data can be committed to or retrieved from the file. Then type, it can be a data, program, document, or master or transaction file. This information is contained in a file label. A file has two labels: header label, which carries all the above information, and trailer label, which contains information about the count of records in the file. Reel number, if the file takes up more than one reel of tape, and a specific field to identify the particular record as a label. Other characteristics of a file include the hit rate. This term now acquires a different meaning from what we had when we discussed about the processor architecture. This term is used to describe the rate of processing of master files in terms of active records. It measures the activity of a file vis-a-vis the total files in the master file records. So if we have, for instance, a 1,000 transaction of files related to that master file against 10,000 records, then we say we have a hit rate of 10%. That's 1,000 divided by 10,000, which makes 10%. In short, file activity or hit rate is a proportion of records updated or referenced on each updating run in relation to the total number of records in the master file. We've just seen that. In respect to magnetic tape files, it is necessary to access each record in a file serially, even though some of the records are not affected by the current transaction. Direct access requires only those records that are affected by the transaction to be accessed for updating. In addition, records stored on a disk do not have to be rewritten to a different disk after updating, since records are overwritten. As a payroll has a high hit rate, there is no advantage in storing it on magnetic disk, for instance, as every employee's record needs to be updated during each pay period. Magnetic tape has a high storage capacity that is cheaper than magnetic disk. On the other hand, a stock file may contain records which are only affected by transaction occasionally. So in other words, if the records stored in a certain storage device are accessed after a long period, the further you move them away from the processor. As simple as that. The other aspect of the file is volatility. This refers to the frequency in which records are added to the file or deleted from the file. So if there is a high frequency of adding or deleting records from the file, then you say the file is volatile. Otherwise, you say it is static, or we can say it's semi-static if it is not if the frequency of adding or deleting is not as high. Then the other property is size. This is the amount of data that is in the file. It may be expressed in terms of number of characters or number of records. The growth files, when you talk of the growth of a file, files often grow steadily in size as new records are added, or shrink as unwanted records are deleted. Growth is with respect to these two aspects: adding new records or deleting existing records. Types of files. We have master files, which are files of fairly permanent nature, like customer ledger, payroll, inventory, etc. And the features of this file include regular updating to reflect current position of the content of a changing field. Again, in this master file, some data will be of a static nature and some of them semi-static nature, like customer name. We have transaction files or movement files, which are made up of various transactions that have been recorded from the source documents. They are used to update master files, and as soon as the master file is updated, their content is deleted. We have reference files. These are files of reasonable amount of permanency. Example of data for reference purposes are price list, table of rates of pay, and addresses. We have document files, which are the simplest form of this is a text file. We are aware of .txt files. Other common forms of document files are used in conjunction with web processing and desktop publishing. We have program files, which are files whose data is an item of software, such as simple program or a collection of programs. These are the files that we call source code files, executable files. They are program files. And even when you go to your hard drive, you're going to see in C there is something that we call program files. We are referring to those files that have to do with applications. Sorry for that. Data files. These are files which contain data as opposed to files that contain programs. I mean, data files will hold data. Some of the data will be used by the program files in execution. Input and output files. These are files which are formed. Rather, they hold process data awaiting output, or they hold data awaiting processing, input data awaiting processing. Then you have work files. These are files which are created during while processing is taking place. I don't know, probably I can give an example. When you're downloading, before you are done with the download, there is already a file that is formed. That's an example of a work file. Scratch file is a file that is no longer needed in the system and is referred to as a scratch file. Access to files. In file organization, we say, what is access to files? Key fields. When files of data are being created, one needs a means of accessing to particular records within those files. This is usually done by giving each record a key field by which the record will be recognized or identified. Such key is normally unique and is referred to as primary key. You know this from your databases. It can be a single key or it can be a composite key. The primary key can also be used in sorting, indexing, and other record manipulations. We have a number of file organization methods. Serial organization means that the records on a tape or disk are stored one after the other. The sequence is that of the first come, first serve. It is mostly used in transaction files or backup scenarios. Then you have sequential files. These ones record the record is kept in the file one after the other in order of sequence of a key field. It is mostly used for transaction files or backup scenarios where hit rates is almost 100%. Now, index sequential. Here in this index sequential is where we have records are stored in sequential file, as in sequential files, but with one exception. An index is provided to enable individual records to be located. You can be able to identify a certain record. It's separable. Each record is separately identifiable. Random access. Here records are stored on a disk in random fashion where there is no logical relationship with the previous or next record in the physical sequence. Then you have data access methods. They are the same, but see the interpretation now. Serial, in this mode, which is applicable where the records in the file are not in any specific order, we have the first record has to be read, the next record, etc. until the desired record is found. That means if you want to access record number 10, you have to go through record number 1 up to record number 9. Sequential, in this the file, method of file organization, records are normally organized in ascending order of a key field. When a new record is added, the sequence is maintained. If insertions, adjustments, and deletions have to take place on a file which is on a tape, of course, that becomes another technique, another issue. It becomes too much work. So it is possible to locate a record on a serially organized disk file without having to read each preceding record, as long as, of course, there has been sorting. So for index sequential is where we have sequential. It allows a sequential file to be processed serially as the records are stored in ascending order. By means of an index, it becomes possible to gain direct access to records for amendment, inquiry, or updating. You can actually access a specific record as long as it was indexed, and then you can also update it separately from the others. Then you have random mode, where individual files or individual records are stored in any particular order or sequence of key fields. They are stored randomly. It is not possible to apply general rules for retrieving records from this type of file, and it is necessary to develop index which indicates the location of each record, or alternatively the application of an address of generation system. Now, how do you make the choice of file organization and access methods? What factors do you consider? We can consider size. Disks and tapes are both capable of storing large files, but very large files can be stored more economically on magnetic tape. Small files can use, of course, nowadays we don't talk of magnetic tapes. We're talking of DVDs, CDs, external hard disks. Small files can use disk space well if blocks are suitably sized and can be easily accessed, but may be troublesome to access if strung in a magnetic tape because of the serial nature of a tape. The percentage addition or deletion in the file maintenance, if low, may allow satisfactory organization of index or random files, but if high, it will make sequential organization more attractive. If a file is likely to increase in size, then the design of the index or random must allow for it. The other factor to consider when you are making a choice of file organization or access method is reference and inquiry. If quick reference is essential, then index or random files will be needed. Otherwise, you can go for the random. Hit rate, if low hit rate are suited, the low hit rate are suited by the index or random files. Yeah, actually more so for the random files. Security of backup. Now, index and random files are overwritten during processing, so they need to be dumped onto a tape or another disk before processing, as well as keep a copy of all transaction between the dumps. We'll see the further sound concept is an aid to security when using sequential files, so that you create another file when you complete an update. Let's look at the file processing activities. A file that contains data and records in it can be accessed. The following major processing activity can be performed. It can be updated. Of course, that means pick what is there, make changes to it, and then rewrite it back. Referencing, it means you can just access it for reading without making any changes, and then yeah, that's it. Maintenance, this means that when you're talking of maintaining of files, it means we can add new records or remove old records. Basically, it's as simple as that. File interrogation or inquiry, same as referencing. Merging two files with a similar structure but different data can be done through merging. Sorting is arranging of records in a file in a certain order. Indexing is organizing a file for direct access by generating an index for every record in the file. Of course, it allows direct access. Conversion, yeah, we can do conversion of a file, transform it from one medium of input to another medium of storage. The file sequencing, we excuse me, do a final check that is made to records in a file to ensure that they are all in the desired sequence. Is what we call file sequence. Collating, which involve merging and matching, e.g. a transaction file is matched to a master file and unpaired records are removed. This leaves only those records that are needed for updating. Simple as that. Now, in section 6.6 we look at updating sequential files on tape and disk. How do we go about it? If you are updating a sequential file on a tape, remember how they are accessed. You have to read all the previous files before you get into that. But even when you get into that, remember, if you remove it and try to add, that space was just a reserve for that particular. It cannot be. What you do is that you get another reel, and in that reel, the updates are done now, as though it is writing new data. So, in file organization on disk, there are 4 basic methods for organizing files on a disk. The first one is serial. So this is the arrangement, same as the one on the tape, stored in first come first served basis. Sequential, again, records are written onto the disk, but in a defined sequence according to the record keys. Can be done also on a disk. Index sequential is sequential basically, but then provided an index to allow for direct access of individual files, good for updates. Random, records are actually placed on a disk at random. These are a little bit risky for access purposes. Now, writing on disk is simple because disk pack has to be loaded onto disk unit and records are written onto a disk pack. It revolves. The disk pack will be revolving at constant speed within the disk unit. Each record is written to the response of write instruction. Data goes from the main storage through a read-write head onto a track on the disk surface. Records are written one after another on each track. When you're reading from a disk, if you want to process the file, the disk must be loaded onto the disk unit. Records are read from the disk as it revolves. And this applies even for DVDs, only that the read-write head for DVDs is a lesser. Data goes from the disk to the main storage through the read-write head, and both reading and writing are accomplished at a fixed number of bytes per second. We know about the speed of a disk. We can see, especially we tell that when you're writing to a CD or when you're burning a CD, we ask about the speed. This is the speed you're referring to here in bytes per second. Access of these files. Serial files, as for tape, this is the only method possible. You access one after the other. Sequential files is common for tape and disk. The access is done as per the record key. Index, there are 3 methods as this. It can be sequential, selective sequential, or you can use random, where transactions are processed in a sequence that is not of the master file. The transaction may in another sequence or may be unsequenced, and the access mechanism will not move in progression as in the case of selective sequential, but forth and back along the file. Here the index is used when transactions are to be processed immediately. It's also used to update 2 files simultaneously. That's random. Now, random files. Remember, we are dealing with access. So when you're talking of random files, generally the method of access is random. The transaction record keys will be put in the same mathematical formula as where the keys of the master records, thus creating the appropriate bucket address. When we want to update disk files, and as individual records are addressable, it is possible to write back an updated record to the same position from which it was read. The effect is therefore to overwrite the original master record with new updated master record. And this method of updating is called updating in place or overlay. In place updating. I think you come across that. The transaction record is read into the main storage. The appropriate master record is located on a disk and is read into the main storage. The master record is updated in the main storage, and the master record now updated from is written from main storage to its original location, overwriting the record in its predated form. That's how the updates are done. And we refer to that as the grandfather-son method of file security. The grandfather-son method is applicable for serially and sequentially organized files, and because they are written on a different disk pack or different location, and in fact this provides further security. That's why we call it the grandfather-son method of file security. Cannot be applied to update in place. This one, update in place, you cannot use it for grandfather-son, because you're referring to what you do in magnetic disk. But for magnetic disk, CDs, that head, you can do the updates, or the hard disk, you can do the updates in place. Maintenance of files on a disk. This is taking time. Sorry, this lesson is longer than the others probably. I don't intend that my video should go beyond 30 minutes. If disk files are organized and processed in the same manner as a magnetic tape, then remarks made in the previous section can apply. These files that are updated using the overlay method present certain problems. When new records are to be inserted, it may not be possible to put them there and then in the sequence of a file. Similarly, if the process of updating a variable records it were to be made longer, it may not be possible to write it back to the disk in its original place. Of course, this we appreciate when you're dealing with these files. The overlay method is not always possible. To cater for such circumstances, an overflow area is usually included in the disk file, and such records as those referred above are placed in this temporary area. We call it the overflow area, and an indication of their whereabouts placed in the main area of the file, which is called the home area. Records that are to be removed from the file have a deletion marker placed on them during file maintenance run. File reorganization. How do you do this? Putting the records that are in the overflow area in the home area in the proper sequence, leaving off the records that are marked for deletion, and rewriting any index that is associated with the file are the steps you follow when you're doing file reorganization. For file organization on tape, I think we have seen that we don't have in tapes we don't have the overlay, but there are two possible arrangements of files in a tape: serial or sequential. That is for obvious reason. We have just discussed writing on tape, we have seen, but remember, when you're writing on a tape, then we have the inter-record gap, and usually the writing slows down when it gets to the inter-record gap. For access purposes, then the inter-record gap or the end of record marker tells the read head on when to stop. If you want, this is the same method used to access sequential files on a disk. The method of updating a sequential file is to form a new master file each time the updating process is carried out, particularly for files on a tape. Updating a master file entails the following steps. 1. Transaction file and master file must be in the same sequence. A transaction record is read into the main storage. A master record is read into the main storage and written straight out again on a new file if it doesn't match the transaction. And of course, successive records from the master file are read and written until the record matching the transaction record is located. The master record is then updated in storage and written out in sequence on the file. The four steps are repeated until the master records for which there is a transaction record have been updated. The result is the creation of a new file containing records that did not change, plus records which have been updated. The new reel will be used in the next update run. This is what we call the grandfather-son method. Sequential file maintenance on a tape. File maintenance on a tape basically takes place in the following manner. It involves basically removal or adding records on to the magnetic field or amending, making changes. That's file maintenance on a tape. And that's it. That brings us to the end of this lesson. I think we have gone through the concept to deal with the file maintenance. It would be good if you can spare some time. Go through it slowly at your own free time so that you can internalize the concept. Also, raise any question you have either by calling me directly, or you can also get to the forum and e-learning platform. You can send a message to me and I'll be able to respond. If there is a forum, you can also use the forum. Thank you. We meet in the next lesson.